Another example of exponential functions applied to finances. 14.17. Inflation is typically around 4%. So our dollar loses 4% of its value every year. Imagine we make $30,000 a year right now. If we do not get a pay raise throughout our 40-year career, how much will we make in 40 years relative to the market, right? Because if you make $30,000 every year for 40 years and you're losing 4% off of every dollar every year, right? If you don't get raises that meet this 4%, then you end up losing money relative to everybody else around you. So let's figure this out. This is going to be a continuous model, right? Because that 4% doesn't happen monthly or annually. It happens all the time. So we will have some initial value times E, Euler's number, to the RT. So initially we have 30,000. That's our initial salary. Now we're going to lose 4%. So this is minus 0.04. Right, that's your R value. Minus because you're losing it, and 0.04 is the equivalent of 4%. So now this is a function of time. So I can ask my question, what's going to be the value of this $30,000 if it loses 4% continuously across 40 years? So I need to put in t is equal to 40. All right, and let's go through this. We'll keep the 30,000 right there. We'll keep the E, and we'll tell ourselves what minus 0.04 times 40 is. That gives us minus 1.6. And E to the minus 1.6 gives us 0.202. And this is an approximation. And now if we multiply by our initial value, 30,000, that gives us 6,056. And some change. So right now you're making $30,000. If you never ask for a raise and you lose 4% across a 40-year career, then relative to everybody else around you, you're going to be only making $6,000.